Hello and welcome to Objective-C programming and OS X development. This is lecture number 3, where we're going to see a few new concepts, few new things. One of the things is categories. We're going to introduce protocols. We're going to see the structure of OS X, of the operating system itself, and how it is layered of different frameworks. And we're going to see one of the most important frameworks and one of the base frameworks that we use all of the time in this course, called Foundation Framework. Before we start, I have to say this. I am sorry. There was a typo in lecture 2, in our previous lecture. We had a reduce function that was meant to reduce our fraction to the smallest standard view. So the last line of that function was dividing the denominator by v, and it of course should be u. It should be the same u as we divide the numerator, because we are dividing both sides until we get to the reduced view. So I'm sorry for that. Please fix that if you didn't catch it yourself, because we're going to use this method and this class in general in this lecture and maybe a few following lectures. We're just building on top of it as we go. Okay, now to the important stuff. Here's a new concept. And when I say new, I mean it's new for us, for those people who are just moving to Objective-C from different languages, more popular languages and more standard languages like Java or C++. It's relatively new and relatively unique feature of Objective-C, and it's called a category. Imagine you have a class, and it's a really big class. It's maybe some mathematical object which you can run mathematical operations on, like addition and multiplication. So you have several methods for that. You can also save this object to a file in a certain way and load something from a file into this object. So you might have few methods for file management. And maybe you have more ways to use this object. You have maybe internet. You might send a message over the internet using that object. So it's a really complicated class. And you have all those different methods in your class definition, and it's fine. But what you would probably do in that big, huge class definition is still group those methods in some way, in logical way, of course. You would maybe put a comment and say, these are file methods, and you're gonna put all the methods that are about file management together, and then you would form another group and you would say in a comment, these are mathematical methods. Now, Objective-C gives you an actual way of dividing your class definition into groups, and it's meant to be dividing into logical groups, of course, but you can divide as you wish. So categories, one of the ways to use a category is to split a definition of a class into different pieces and implement them separately, but it's still a single class. And if you create an object of that class, you can still call any method from any group. So for that part, nothing changes. Another use of a category is extending an existing class. So if you have a class and you want to build on top of it, maybe add something, one of the ways that you have provided by object-oriented programming itself is, of course, inheritance. You have a class, you want to do something more with that class, you create a subclass, you inherit from that class, and you add new stuff. But sometimes it's just too much of a hassle, and another way to do it is maybe you just want to have one small method added to that class. You can do it with a category. You can just extend the class you already have. Nothing changes to the class. You're not actually touching the class. You're just putting something that could be used as if it was part of the class. Okay, well, that's all fine. Let's just see how it works. I have Xcode running here, and as you can see, it's the same fraction class we were working on the first 2 lectures. The only thing changed here is, of course, well, I fixed the typo. It's division by u. And I have added a method called setToOver. And this is a method that just sets the numerator and denominator in a nicer way. Using this method, I can do something like this. I created two fractions, and one of those fractions is set to 2/4, and another one to 2/5. And we can still use set numerator and set denominator because we have them as properties here. And we synthesize those setters and getters in the implementation of our class. But this is just nicer. And as you can see, we're using add, and in the add we have a reduce method being called. Okay, so let's see. I have this fraction class, and I decided to have all my mathematical operations like addition in a separate category because it makes sense. I want just to have all the math operations separate. I have to define a category. When you define a category, you have to have the class you're building on top of already present. This is why if your category is in a separate class, you have to import your original class header file first. In our case, we have everything in a single file. We don't have to import, but we have to keep the definition of our category after the definition of the class itself, because if we put category here, the compiler will complain because it couldn't find the class building on top of. So let's just try. This is how we create a category. It's actually sort of building a class. I'm saying interface, and I'm putting the same class name as the class you are extending from. So I want to extend fraction. I put fraction. And in the brackets, I would say the name of my category is math operations. And I'll say and. Xcode already complaining. It says I cannot find the definition of a class called fraction because it's not there yet. When compiler is on this line, it didn't reach this line yet. It doesn't know about fraction class. So I have to move these here. Okay, so this is just like a regular interface. All I have to do here is put the definition of our method I want to add. So the idea is you have some new methods here and you implement some new methods for the class. I want to save time and I'll just have this method moved. So the add method that we used to add fractions, I just delete it. I don't want it in my class itself. I want it into inside a separate category. So I paste it here. Okay, that's it. Now, one of the things that differs categories and classes is you cannot put variables here. You cannot create variables in a category. So a category is only for methods. It's only a way to extend a class by adding new methods. I don't need this line. Let's just make it simpler. Okay, now it's time to implement this. Now, the idea of category is just having a separate instance to extend the functionality of your class, but don't touch the original class. So we're not touching the interface of our class, and we're not touching the implementation of our class. We have to write a new implementation for this category, so for this method. This is why right here I'm going to put implementation. And I'll just put math operation as a category and of course the fraction itself. So This is exactly the same syntax as a class implementation, but we are implementing a category method. So we have add function, and we already have it implemented here. So we're doing the same. We just delete it from here and paste it here. And here's another problem. This numerator and denominator variables are not defined yet because we decided to define them here, to not actually define them, but define the getters and setters to synthesize. So when we're saying numerator equals, we are trying to call the setter. So this is why this implementation should go after the implementation of the class itself. And now we have no issues. And if we run the program, we're going to see exactly the same thing that we used to see. So this is a category. And here is just the formal definition of how to use it in a class. As I said, first of all, you have to have the class itself present in a namespace. So you want to import your class name if this category is being defined somewhere else. Then you create an interface and you use the class name you want to extend on, and you put your category name. So you define a name for a category and then define all the methods. So here's the space to define methods, but not variables. And then you implement this category by doing the same thing, but with the implementation keyword. And of course, here you do actual implementation. You put the code for all of your methods. There's no limit on categories, so you can create as much as you want. And the combination of the class and the category is unique. So here we created class name, category name, and you cannot create another category with the same name for the same class. But you can create the category with the same name for another class because the pair class category would be different. There is a way to actually extend the class because, well, adding new methods is just half of the story. Sometimes if you want to extend the class, you want to add new variables. And a way to extend the class is just to create a category without a name. So let's see how that works. But actually, I just said everything we needed to know. If we delete the name here, and then instead of doing that, because here it expects a name for a category, we actually extended the class itself. So we can move this back to the class. Delete these. So here we have the interface fraction, our class, and we sort of have the same interface for a fraction, but with empty brackets, with no name for a category. What we did is we actually added this method to the class itself, and we have to implement it inside the class. But the good thing is we can create new variables here. So we can say int ID. And of course, we need to follow the same syntax here. We need to put those in a bracket. So this way you're adding not only methods but variables to your class as well. And here is the detailed explanation of all I just said. Instead of implementing the category, you just have to actually implement all the methods you defined in the class extension inside your class implementation. Any category, both named and nameless, can override a method in a class. But don't do it. This is just a bad practice. The problem with overriding a method in a category is if you do that, you actually replace the original method, and the original method would not be accessible from anywhere, so it's lost in your program. What I mean by overriding is so we have a print function here, and this meant to be adding. Category is meant to be for adding new stuff, not replacing stuff. But we can replace. So I can say print is now this function. So it will work, and it will call a new print function. Well, actually, that makes sense if I actually create a new cat name, but etc. You get the idea. If you implement a new print function, then the original print function will be unavailable, so you won't be able to call the print function. If you really need to override, I'm afraid you have to create a subclass. In this case, the original method will be available, because from your class, from your object, you can call your parent object using the super variable. And you can still access the original method, the method you overloaded or overwritten. So just remember, don't override a method in a category. Okay, it's pretty easy. A category is just a group of methods. A protocol is kind of similar idea, but for multiple classes. A protocol is a list of methods shared among different classes. It's just a list. It doesn't force you to implement those. So if you create a protocol, you're not forced to implement those. You can just have this list. And one of the ideas of having a protocol is you have written a protocol and other programmers are going to write classes. And if you want your classes, the class you've written and the class some other guy is going to write, to be compatible, to do sort of the same stuff, to maybe talk using the same language, is if both classes adopt or conform the same protocol, meaning they implement those methods in this protocol. Some methods in your protocol could be required and some could be optional. And if a class implements all the methods that are required, we can say this class conforms to a protocol or adopts a protocol. And again, let's just see an example. So I don't need this. I don't actually need any of this. Okay, let's just put it all here. The way to create a protocol is obvious. I say protocol. And I want to create my protocol. So inside the protocol, I'm going to have a list of methods. And if I just put methods here, I'll say maybe this would be a void method called, not maybe void, but integer method going to call get ID. So all the methods I put here are considered to be required. And if I want to put methods that are optional, I put optional keyword. And here I'm gonna say get something else, get number, etc. So everything without the keyword is required, and if I want to put something optional, is optional. If I want to go back to listing required, I can say required. I'm not going to do it here just for the sake of this example. Okay, so this is a protocol, and it doesn't force us to do anything. We can still compile and run our program. But if we want our fraction class to conform to this protocol, we first of all have to say that we're using that protocol. We're trying to conform. So we have our fraction class here, and yes, it inherits from NSObject. And if I want to state I'm trying to conform to a protocol, I have to put the protocol name here. And again, if I'll just try to add my protocol here, it will complain because, well, my protocol is not defined yet. Now, protocol is a thing by itself. It doesn't belong to classes. It doesn't do anything with classes. So we can put it here because we don't need anything to create a protocol. So now our fraction class conforms to a protocol. And we have this new warning message in Xcode, and it says method in protocol not implemented. And that's true because we have this method called getID, and it's required. And we're saying we're conforming, but we didn't implement getID yet. If I actually click here, it will say incomplete implementation. Yeah, all right. So we didn't have to do anything with the interface except for stating my protocol, but now we have to put the definition, no actual definition, but implementation of getID. So I'll just do something. It already knows that I have a method getID in my protocol, so Xcode is really smart. And I don't need to get fancy, just return 42 because that's the answer, right? So now we have no issues because we actually implemented that. We can say the fraction class adopted the my protocol. Now, this example is kind of stupid. It doesn't make any sense. But if you have, let's say, a number, and some other programmer decided to have another class for a number, for another type of the number, but you still want to have it in sort of a common pool. You want to use some common methods. So you just decide on a protocol and then distribute this protocol to all the programmers. And all programmers have to make those their classes adopt this protocol. If they do, you can use it together. Okay, here is a formal way of describing a protocol. Yes, we have a protocol, optional when required. And in the interface, we have to put the protocol name. And in the implementation, we have to put actual implementation of a method from a protocol. A protocol is classless. It doesn't belong to any class. It doesn't reference any class. It's just a completely separate business. Any class can conform to any protocol if it tries really hard. You can adopt several protocols, and this is not like multiple inheritance. You're not inheriting anything. You're not getting different stuff. All you're saying is our class name here, so my class, is going to implement all the required methods from those two protocols. You can check the conformance. So if you have an object, you can check if it conforms to a protocol. And if we inherited from NSObject, we have this method called conforms to protocol. And if we send a protocol to that using the protocol keyword and protocol name, it will reply with the yes or no. And if it's yes, we can use methods in this block. If you have optional methods there, it could still conform but not implement some of the optional methods. So we can call response to selector. And you might remember this from the last lecture when we were discussing methods built in NSObject. And since we inherited most of the stuff from NSObject, then we can use things like response to selector. And again, if we have a selector called myMethod, no matter where the selector is written, if it says yes, we can actually call that my method. Okay. You can put the protocol name before the definition of your object, of a variable. So here we're creating my object, but between the type of the object and the name of the object, we're saying my protocol, and this is the name of the protocol. And this will tell the compiler that my object will reference an object which conforms to my protocol. And if at some point I'm assigning some other object to this variable, some other object that doesn't conform to my protocol, the compiler will issue a warning. So this is just kind of getting help from the compiler. If I know that I'm going to use only the objects that should conform to this protocol, I might say this if I'm sure, and if I made a mistake and assigned another class that doesn't conform, I'm going to be warned by the compiler at compile time. There are three things you have to remember about protocols. First of all, just like with categories, you can put several protocols in this object definition. So you're saying my object will conform to my protocol and another one, which is another protocol. You can extend existing protocols. So this is sort of inheriting a protocol when creating a new protocol. And it's sort of the same syntax even. When I'm creating a new protocol called another protocol, I'm putting this protocol. I said a lot of the words protocol in this lecture, protocol. So I'm saying here, I'm inheriting stuff from another protocol, and if my class is told to adopt another protocol, then it should also adopt all the stuff from my protocol. So they are compiled together in a single huge protocol. And last, categories can adopt protocols too. So if you are extending a class using a category, then you can say this category adopts a protocol. And in your implementation of a category, you should, of course, implement all the methods that are required in protocols that you decided to adopt. Okay, hopefully this is it for protocols, but not yet. There's another thing, and this is more of a history thing. Sometimes you will see informal protocols, and hopefully not too much, because informal protocols was just a category that lists some methods but doesn't implement them. And this pattern is no longer used because in Objective-C 2.0 we had this new thing. In the protocol we had an optional keyword. As I showed you, you could have methods that are optional to implement. So you can still conform to a protocol and not implement some of the methods because they are put in optional section. Now, before we had this idea, we only had a protocol that has required methods. And there was no way to say, well, here's the method, you may or may not implement it. It's up to you. So they used a category and just listed all those methods that are meant to be optional. So in NSObject, there used to be methods like is equal to. And of course, in generic NSObject, there's no way to say if two objects are the same. And in our fraction, we would write our own is equal to method because it depends on the class we're writing. In our fraction, we would compare reduced fractions or compare numerator and numerator, then denominator to denominator. In other object, you would do the other stuff to say if they are equal or not. So they had this method that wasn't implemented yet, but was up to you to implement. Okay, that's it. We have categories, we have protocols, we can extend classes, we can create some common languages for multiple classes, and it's all fine. Let's actually see what our program consists of. And this brings us to our topic of a framework. And I was talking about frameworks last 2 times, and you hopefully get the idea of a framework, but just in case, here's the formal definition. A framework is a collection of classes, methods, functions, and documentation logically grouped together to make developing programs easier. And the key word here is easier. A framework is just a bicycle you don't have to invent. A framework gives you a lot of the things that you would do by yourself and spend a lot of the time. And since you are doing it and other guy is doing it, well, maybe it makes sense to do it once, to do it properly, to give all the documentation, to give it a really nice and useful structure, and then just use it. And this is the idea of most of computers today. This is the idea behind that an operating system. An operating system is a set of different things that we do. And instead of when you create a program, you don't worry about, let's say, putting pixels onto the screen. And in the early days, where people were doing programs for computers without operating systems, so they had to write every single thing that happens in their program. So when you today creating a program that prints out the sum of 2 numbers, it takes you like 5 seconds because everything is there. The definition of a number, the definition of a screen, the function to put a number to the screen, etc. 50 years ago, they didn't have this awesome thing like an operating system or a framework. So they had to write everything on their own. And then they thought, well, I'm doing it, you're doing it. Why are we doing it? Let's just get together and think really hard, make it really nice, and put it there. So we don't have to write it every time. So they started to putting it there, started to implementing all the main functions, and to do it in such a way that it's extendable, it's changeable for your task, but it's also has some sort of standardization. And this is how basically operating systems started. They just built a lot of stuff that they didn't want to write every time they write programs. And building on top of that, they created a thing called operating system. So operating system is just basically a huge framework. Modern operating systems are super complicated. They are awesome, but super complicated. And awesome operating system like OS X has multiple layers. And here's an idea of different layers. If you're creating a program, you have some foundation. You have those things that you don't want to worry about. It's like when you're building a house, you're given the core. You're given all the main 4 structures. And it's your house, so you decide what type of roof to have and what type of windows to put and what type of door you like. So those things are your application code. Those things are implemented by you, but there's some foundation that you don't have to worry about. But you can change if you want, but most of the time you're using all the same things that many other people use. So OS X has this layered structure. Just like other operating system, it starts with a kernel. And in this course, we're not talking about kernels and operating systems much, but last term I was teaching in operating systems course, and hopefully if we are moving with the same idea of video courses, next year I'm going to have this course recorded. And if you want to know much more about operating systems and its structure, next year, hopefully you will be able to see it just like this one. So there's a kernel, there's a core of the operating system, and some drivers for devices. So your mouse, a keyboard, and the screen, it's all there. It's operated by the most low-level thing in your system. There is some core operating system functions those functions work with memory and disk. This is why when you're saving a file, you have no idea how disk works, and you don't really know if there is a disk and if that disk is on your computer or a computer across the planet. This is why we have it in a separate layer, which is abstract for us, and this is why we can just say save file and have no idea about disks and heads, etc. Then we come to actually some frameworks that we touch in this course, and those are foundation and core data frameworks and core services. Then we have some media frameworks, and the most high-level framework called AppKit, and the API to use that AppKit is Cocoa. So the idea is, if you can, use the most high-level framework, because if you can use them, that means most of the stuff is written for you. Most of the stuff you don't have to worry about. So when we created a web browser in the last lecture, we didn't worry about windows, about buttons, about HTTP browsers, connecting buttons, etc. We have it all there in the framework. Okay, let's see in all those layers a detail. First layer is called the foundation framework, and this is the basic framework that we use. So all the basic objects like strings, numbers, all the collections like sets, dictionaries, arrays, all the dates, times, stuff to work with the file system, storing and loading objects, archiving objects, and most fundamental geometric data structures like points, rectangles, triangles, etc. They are all in foundation framework. So these are the most low-level things that we're going to touch. Of course, we're not going to worry about how different commands are executed on a CPU, etc. The most low-level stuff for us is basic data types. The next level is core data framework, and this framework we're not going to get too much detail into, but it's used to save and retrieve objects from storages, support basic undo redo, so it mostly works with memory. And two frameworks that we're going to use in this course are Foundation and AppKit, so the most low level in this structure and the most high level. Okay, next three frameworks are for the media, and there's a core animation framework that allows you to create custom animations, add timing functions to graphics you use in your program, support keyframe animation. So basically everything about animation is on this level. And when I say on this level, it's not that this is something we can use. This is something we can use, of course, but this is something the operating system itself uses. So when you created your web browser last lecture, you could minimize it, and it would nicely minimize using Qt animation, which is built in the operating system. And that animation was possible because of this layer, because there is core animation layer and some standard animation functions. But you can create your own using this framework. The next one is OpenGL, and that framework is for 2D and 3D graphics. And again, everything 2D and 3D in the operating system is implemented using this framework, and it gives you an ability to make your own 2D and 3D graphics. So it allows you to make more complex graphics such as data visualization, maybe flight simulation and video games. And if you decided to create a video game, you have to learn OpenGL, and you have to learn all the functions that are used in this framework. You can use multiple threads to process graphics data and access underlying graphics hardware using OpenGL. And the most top-level framework in the media is, well, I'm sorry, I forgot to move this arrow. It should point here, of course. It's a core graphics layer. It allows you, well, Yeah, just clicked the wrong arrow. It's actually here. The arrow is here, and it's the mistake. My mistake here is this shouldn't say OpenGL. It should say Core Graphics. But text is right. Core Graphics makes it possible to create path-based drawings, use rendering, use gradients, images, colors, and have transformations using coordinate space. We're not going to touch this neither, but remember, those layers are working all of the time when you're using your program. So the layer we're going to use and to spend most of the time in this course is called AppKit. And the Cocoa is the API. It's the way to use this framework. It's the way to access all the methods in this framework. It gives you an ability to construct and manage your user interface, to handle all the events by the user, to present fonts, colors, images, and all the media, perform basic animation, and support basic app features that are used in the operating system itself, like spaces, universal help, multiple user accounts, etc. It also allows you to create custom user interface elements as well as use all those that comes with it, all the standard ones. So in the last lecture, in the web browser, we only used built-in elements like buttons and text fields. You can also create your own using this framework. Okay. You have to remember the idea of how applications work on this operating system. When you run an application, it draws the application on the screen. It puts all the elements that there are, and then it waits for events. And events, most of the time, are events issued by the user. Clicking a button, moving a mouse, doing something, typing something on the screen is an event. And something non-user based, like maybe a message from the internet or something 10 o'clock, some time happens, is another type of event. So when some event happens, the application may react to that event. It goes all the way through the operating system. It goes into a queue of events. So sometimes your computer is really slow. It might be because the queue of events is full and is trying really hard to make it go. And then this event goes to the application if that application was waiting for that event. And the application, of course, reacts. It's a long way, but for the end user, most of the time, it seems instant. The framework that we used in these 3 lectures, so stuff like NSLog and NSObject, NSString, and NSNumber, are all parts of the Foundation framework. And there's a lot of documentation on Foundation. This is why we're not going to touch much about Foundation. And this is why I said for the Lab 1 and Lab 2, just go there and find out how to use arrays and find out how to use numbers, because it's all there, it's so easy. In Xcode, you have full documentation. So if you go to Help in the menu, you would see all of the documentation for Foundation Framework. You can also option click on anything. Like here we have NSLog. And if I hit Option on my keyboard and click on it, I will see a short documentation on NSLog. And if I click here, I'm going to the Help chapter for this NSLog, and I can also see the actual NSLog header file. There's also a quick help on the right. So if I enable this utility screen, by default, I'm looking at all the fields for my object, but there's also another tab called quick help, and that gets updated every time I move my cursor. So here I have void, and not much about void, but while. Okay, let's see if I can get helpful. If I put it on my fraction, we know the fraction inherits from NSObject, and it knows about NSObject. That's why we have NSObject here. And if I have my protocol, there's not much, but we can at least see what it's declared. So most of the things you can get help about in this sidebar. So it's really easy to follow. There are numbers in Foundation Framework, and the most used class for that is NSNumber, and we used that before. And just to recap, here we have an NSNumber and 3 different numbers, and it's a class, it's an object. We're going to see an object. This is why we have to create pointers. So we created 3 NSNumbers, and NSNumber could take a value of different data types. So it could be an integer. So here I'm saying this int number is NSNumber, which is a class, number with integer 100. This will allocate space for an NS object, NSNumber, and initialize it and set it to 100 and make it an integer. So then I can say my int, which is just NS integer, a simple data type, no pointer, to have my int number integer value, and this will return the integer value of that number. I can do the same with long, and I can do the same with character. Character is just a way of storing a character as a number. And we can do the same with the float and double, quite easy. You already seen strings in Foundation Framework. So you were printing something like this in your NSLog, and NSLog accepts NS string, and just brackets, those symbols will make it a C string, and the @ symbol will make it NS string. So this actually creates a NS constant string, a string that is immutable, a string that you cannot change. And it's a subclass of NS string, and there's also NS mutable string for strings that you can modify. So NSLog accepts all of the objects with the @ symbol. So remember, when you were to print an integer, you would put I here, just like in C or C++ actually. But here we can print an NS string. We can just say @str, and we'll print what you know. But you can create your own way of printing. So our fraction, let's see, we can just create a description method which is going to be used in this call. So in our fraction, if we want to print our fraction, what we did here was NSLog and then print the numerator and denominator. Here we were calling the print function on my fraction, but if I just put NSLog and put this class, this object, then it would be garbage. I want to have my own way. I want to do this, basically. I want to say NSLog I want to have this. And I don't want this. To do it, I have to override the description method that comes from NS object, and that method returns NS string. Actually, pointer, of course, it's a class. We have description here, and we're going to return a new NS string with format, and the format would be that over another integer. So basically just recreate the print method. And now we can print it in NSLog because we overridden the description and we get the same output. Okay, and last thing is arrays. And again, there's not much I'm going to talk about because first of all, this is the end of the lecture. And second of all, if you passed the lab 1, I believe you already know about arrays. And there are two types. There's an immutable array, which is NS array, and there's an NS mutable array, an array you can change. And the difference is array holds objects, so objects could be of different types. And that's it. So starting with the next lecture, we are moving on to actual visual stuff. So just bear with me and it will get more exciting. Thank you and goodbye.